Welcome to your Algebra 2 Lesson 1.6. Today we're going to solve linear inequality, so obviously that's the objective for the day. A linear inequality in one variable can be written in one of the following forms where a and b are real numbers and a is not equal to 0. So we have ax plus b less than 0, ax plus b greater than 0, ax plus b less than or equal to 0, and ax plus b greater than or equal to 0. A solution of an inequality in one variable is a value that, when substituted for the variable, results in a true statement. The graph of an inequality in one variable consists of all points on a number line that represents solutions. Alright, to graph x less than 2, the solutions are all real numbers that are less than 2. 2 is not included, so we need to use an open dot on the number line at 2 because that indicates that 2 is not a solution. Now, if you were taught to actually show your coloring in on the number line above or below the number line, that's fine. Or you can put it right on the number line, but you want an open circle at 2. The values that are less than 2 are values like 1, 0, -1. So we are going to color in the number line in the direction of negative infinity. We're going to go to the left. For x greater than or equal to -1, our -1 is going to be where our solution starts, but this time we need to indicate that we include -1. Okay, it is actually part of the solution, so we use a solid dot there, a solid endpoint. So again, whether you color in this arrow going to the right and the solid dot, whether you do that on the number line or above it, that's fine. But again, we do want to go in the right direction because the numbers that are greater than -1 are to the right. It's colored in at -1 because we want to include that endpoint. All right, let's look at a compound inequality. We're going to graph -1 less than x less than 2. That means x is bigger than -1 and less than 2. So -1 is less than x and x is less than 2. So you look, since this is a strictly less than, we're going to use an open circle at -1. Since this is a strictly less than, we're going to use an open circle at +2, and then we color in everything in between. Okay, we're going to graph x less than or equal to -2 or x greater than 1. So this means any number that makes one of these pieces true. Or is easy. You just satisfy one or the other of them. So the solutions are all real numbers that are less than or equal to, because it's got the little line underneath it, -2. So -2 gets a solid dot, solid endpoint, and then we go to the left. Or greater than +1, so we do an open circle because it's strictly greater than +1, and we go to the right off into the direction of positive infinity. And so we have two actual portions of the number line representing solutions. One that satisfies x less than or equal to -2, that's this region here, and one region that satisfies x greater than 1. Now, solving linear inequalities, there's a few things you need to remember. Just like with equations, you can add or subtract the same number from both sides of a linear inequality and you will produce an equivalent inequality. Now, with multiplication and division, you have to be a little careful. As long as you're multiplying or dividing both sides of the linear inequality by a positive number, it's just like with equations, you're going to produce an equivalent inequality. Where you have to be careful is if you are multiplying or dividing both sides of the linear inequality by a negative number, you have to reverse the direction of the inequality because you're shifting the weight. Whichever side was bigger than the other one before, boom, becomes smaller. So you have to reverse the direction of the inequality when you multiply both sides. Multiply or divide both sides of a linear inequality by a negative number. As long as you remember to reverse that direction of the inequality, you'll still produce an equivalent inequality. Okay, so let's look at this. You have $50 to spend at a county fair. You spend $20 for admission, so just to step in, you spend 20 bucks. You want to play a game that costs $1.50. Describe the possible numbers of times you can play the game. Okay, that's the only game you really care about playing. It's a lot of fun. So let's look at this. So You're going to write a verbal model and then write the inequality. So you got to pay the admissions fee. So you've got the $50 in your hot little hand. You got to pay the $20 for the admissions fee. And then every time you play the game, you have to pay the cost per game, however many times you play it. And all of that has to be less than or equal to 50. So you've got your $20 plus the $1.50 you're going to pay for each game, and that has to be less than or equal to 50. So your inequality statement is 20 plus 1.5 times G is less than or equal to 50. Okay, so you write it down. Well, what's the first thing you actually do? Just like the first thing you do when you walk into the county fair is pay that $20. It's the first thing we're going to do. We're going to subtract 20 from both sides. And so you have $1.50 times G that has to be less than or equal to 30. Divide both sides by 1.5, $1.50. So the number of times you play that game has to be less than or equal to 20. So if that really is the only game you want to play, you can play it up to 20 times. If you get bored with it, after 10 times you're good. If you want to play it 22 times, you're out of luck. Okay? You can only play it 20 times or fewer. All right. Let's look at solving an and compound inequality here. So it looks like one we saw in a previous problem, but this time there's some solving to do. We've got -4 less than 6x minus 10 less than or equal to 14. All right. Well, you know how usually we do something to both sides of an equation or both sides of an inequality? This inequality has 3 sides to it, a left side, a middle side, and a right side. So anything we do has to be done to all 3 sides. I want to isolate x, so the first thing I'm going to do is I'm going to add 10 to all 3 sides. Okay, so -4 plus 10 gives me 6, less than 6x minus 10 plus 10 gives me 6x. Less than or equal to 14 plus 10 is 24. Now I'm going to divide all 3 sides, all 3 parts or each expression by 6 because I'm trying to solve for x. So I get 1 less than x less than or equal to 4. 6 was a positive number, so I didn't have to worry about reversing any inequality sign, so we're good to go. So my solution is 1 less than x less than or equal to 4, and on the number line, that's going to be all real numbers starting at but not including 1 and going to 4 including 4. All right, let's solve an or inequality statement. This is our last example, always a happy occasion. So we're going to, a solution for this compound inequality is a solution to either of its parts. Okay, or is easy. You only have to satisfy one statement or the other and you're part of the solution. Okay, so let's do the first inequality. You almost work this like 2 separate problems. So 3x plus 5 less than or equal to 11. We're going to subtract 5 from both sides to get 3x less than or equal to 6. Divide both sides by 3 and we get x less than or equal to 2. Let's do the second inequality. We're going to write it down. So 5x minus 7 is greater than or equal to 23. Add 7 to both sides to get 5x greater than or equal to 30. Divide both sides by 5 to get x greater than or equal to 6. So we're going to put both on our number line. Now, just to make this clear, your solution would just be x less than or equal to 2 or x greater than or equal to 6. Graphed, the way it looks is x less than or equal to 2. You draw in a solid endpoint at 2 and shade to the left. For x greater than or equal to 6, we would draw in a closed endpoint and shade to the right, and that is going to be our solution represented on a graph. Okay, guys, that's it for examples. So you need to do the problems to try on your own. Remember, that's critical for getting full credit for your notes. If you can't do the problems to try on your own, go back and watch the video again. And then if that doesn't work for you, or if you'd rather, just come on in and ask me for some help, and we'll get you ready so that you have those problems done when you get to class and you get full credit on your notes. Okay, guys, I'll see y'all soon.